Hey, welcome. Today, we're going to break down a new way to think about AI that could seriously change how you work, how you learn, maybe even finally help you start that massive project you've been putting off. Let's get into it.
You know that feeling, right? You've got this big idea, maybe it's a report you have to write, a new skill you want to learn, a whole creative project you're trying to get off the ground. You sit down, you're ready to go, and then nothing. You're just staring at a blank page, an empty timeline, and the whole task feels like this giant physical wall.
So let's just call this what it is, project paralysis. It's that invisible wall, that inertia that just stops us cold before we can even take the first step. And look, it's super frustrating, but it's not some personal failing. We all hit it. And here's the crucial thing to understand. This isn't you being lazy or unmotivated. Not at all. There's actually a scientific concept that perfectly explains what's happening. And once you get it, you can beat it. It's called activation energy. Okay, so this lays out the problem perfectly. See that bar on the left? That's you, right now, your current mental energy. But to get your project done, you have to get over that huge energy barrier. That massive gap between where you are and where you need to be, that's the activation energy of your task. It's a beast. So, how in the world do you get over that wall? Well, the answer, and this might sound a little weird, comes straight from high school chemistry class. Yep. Turns out the secret to getting things done is kind of hiding in a test tube. In chemistry, activation energy is the absolute minimum amount of juice needed to kick off a reaction. You could have all the right ingredients sitting in a beaker, but without that initial energy boost, they'll just sit there forever. Nothing will happen. Sound familiar? So here's how chemists get around this. They don't just try to force it. Instead, they add something called a catalyst. The catalyst's one and only job is to lower that energy barrier, making it way, way easier for the reaction to just start. It doesn't do the work itself. It just makes starting the work effortless. Which, of course, brings us to the big question. If a chemical reaction needs a catalyst to get going, and our own projects have this huge activation energy barrier, what's the catalyst for our thinking? This is where this whole new mental model clicks into place. I want you to meet the AI enzyme. From now on, think of AI not as a coworker or a robot replacement, but as your own personal catalyst for any tough mental work you have to do. Just look at this side by side. It's almost perfect. A chemical enzyme is made of proteins, and its job is to lower the energy needed for a reaction. Our AI enzyme is made of algorithms, and it does the exact same thing for a mental project. It just crushes that initial energy barrier and accelerates your thinking. And this isn't just a fun little analogy. The source material puts it perfectly. Think of AI as an independent variable. It's a tool you bring in on purpose, specifically to lower the activation energy you need to get started on a project or learn something new. Okay, so the theory is cool, right? But what does this actually look like day to day? Let's talk about how you can actually use this AI enzyme to smash right through that wall of project paralysis. Say you're a writer and you're just staring at that blinking cursor on a blank page. Use the AI enzyme. Tell it to spit out 20 different headlines, or ask it to create a rough outline for your script. It's not writing the article for you, it's just destroying the activation energy of starting from absolute zero. Or if you're a student, oh man, this is a total game changer. Instead of getting overwhelmed by a 50-page academic paper, have the AI enzyme summarize the key points. Ask it to explain a really complicated theory like you're 5 years old. It takes that first intimidating step, the one that makes you want to just quit, and makes it easy. Because look, here's the bottom line. The goal isn't to get AI to do 100% of the work. The goal is to use it to just handle that awful, high-friction first part of the task. We're talking about reducing that initial effort by like 90%. It just gets the ball rolling so your own brain, your own creativity can take over. So what's the big takeaway from all this? It's simple, really. The hardest part of doing great work usually isn't the work itself. It's just starting. And when you start thinking of AI as your personal catalyst, you've suddenly got a tool that is specifically designed to get you over that hump. And you gotta remember, in the lab, the scientist is always in charge. The enzyme is just a tool they use. You are still the writer, the student, the creator. AI is just the enzyme you add to the mix to get your experiment started, faster and with a whole lot less friction. So I'll just leave you with this thought. If that huge wall, that activation energy that's been holding you back, suddenly vanished, if that first impossible step suddenly became easy,
what would you finally build?